What we do in recycling of the cuttings is you're able to get some type of value back out of what you have generated as a waste and turn that into a legitimate product.
This is EnergyCast, and I'm Jay Downhauer. Today we're heading back to the oil patch to talk about drilling, specifically the byproducts of oil and gas production. Just like sawdust when you use an electric drill at home, oil and gas operators produce bits of rock from drilling operations collectively known as cuttings. For years, these cuttings were simply discarded, landfilled, or thrown away. But our guest today has developed a method for cleaning these cuttings up and using them for paving materials out of the oil patch. The volume of drill cuttings has exploded with the fracking boom and the increased use of horizontal drilling, which is when a hole is drilled down and then across, sometimes for miles. A single well site or pad often has about 20 horizontal wells, which run parallel underground so that the operators can perform what is known as a zipper frac. With multiple wells, miles each, drilled on a single pad and multiple well pads on a single lease, you can expect a mountain of cuttings. If you've spent time in the oil field like me, most likely you've traveled miles on unpaved lease roads heading out to a frac or a well site. I've seen lease roads across the country. Sometimes they're dusty farm roads like West Texas. Other times they're paved with rocks called caliche, which is also used for the well pad. The point of this material is that it is easy to lay out, firm for all the heavy equipment rolling over it, and eventually easy to take up. You'll remember my Select Energy episode where my guest expressed his preference over wind power.
I tell you what though, if I lived on a beautiful ranch house with 1 million acres behind that ranch and I had the choice to put wind power out there in that field or frack the hell out of that field, I would frack that field. Because 10 years from now, it'll be a beautiful field.
A lot of these roads are not meant to stick around forever. In fact, many of the pads and roads that were so prevalent during active fracking operations go away once production ends. I've gotten in trouble more than once following a Google satellite image of a lease road, only to learn after traveling for miles that the road on the image no longer existed, save for a few dozen heads of cattle. Our guest today is Blake Scott, president of Scott Energy Technologies in Longview, Texas, a company with over 20 years in the oilfield services sector. However, unlike my experience where I've recycled water, Scott's technology focuses on recycling the drill cuttings and using them for road construction materials. I love this technology. As we've discussed in the past, the oilfield sector is fraught with largesse, and any company that can help that industry do less with more is a winner in my book. Just like how Capstone Technologies is helping operators use flare gas to fuel combined heat and power units. I met Blake through Christian Goff, a public relations expert I knew back in Austin. She and I would attend weekly legislative update meetings back in 2009, and she reached out to me when I started this podcast and asked me if I was interested in talking to Blake. As you will see, we touched on some really cool topics, such as are oilfield operators more likely to try out a new service when times are tough or times are great? We also discussed using a technology such as this in different regulatory environments. Scott is recycling material from deep within the earth, and some of it can be a little nasty. For years, I've thought of regulation-heavy states in the Northeast as overly heavy-handed, but after you hear from Blake, you may change some of your perceptions as I have. One more note before we start, you'll hear the term upstream in relation to the oilfield industry. For my non-oilfield listeners out there, upstream is the exploration and production phase, midstream is the processing, storing, marketing, and transportation phase, and downstream is the refining, distributing, and retail leg. Got it? Great. With that said, I hope you enjoy my conversation with Blake Scott. We're here with Blake Scott, president of Scott Energy Technologies in Longview. And Blake, we've covered oilfield services before. We spoke to Select Energy Services about water recycling and transfer, but what you're doing is quite different. How so?
Jay, thank you for having me. One of the differences has to do with the waste itself. If you look at oil and gas waste, you have produced water, and that produced water can either be what people view traditionally as coming up during production or flowback water. And then you have other types of waste, such as drill cuttings, and then what the API and the EPA term as associated wastes. Basically, we deal with the drill cuttings or the drilling waste, and that's a solid waste, unlike what Select is dealing with regarding recycling of water, which clearly is a liquid. And that's a big issue, the recycling of liquid, and it's definitely something that has a phenomenal amount of benefit, especially given the fact that the largest waste stream that the upstream E&P industry produces is produced water. The largest solid waste, though, are drill cuttings, and that's the material that's generated when you drill a well, and the solid particles that you're drilling through come to the surface via transportation by the drilling mud, and then they're separated at the surface by solids control equipment, and the solid particles with some associated mud is left behind, and that's the drill cuttings.
One of the things that I've dealt with before, we've done some water treatment where we would do sludge drying, and we would sometimes deal with potentially radioactive material. Norm, are you seeing anything come up in drill cuttings that's potentially hazardous, such as that? What are these drill cuttings usually like?
First of all, let's talk about the radiation aspect. There have been several studies that have been done. Pennsylvania has done one of them in looking at what is radioactive in upstream waste. Typically, drill cuttings have very little radiation that would pass an actionable level associated with them. Now, that doesn't mean that other upstream waste don't have more radiation that they have to deal with, and typically that would come in the form of like tank bottoms. So for cuttings themselves, there's typically very little radiation involved in them by the studies that have been done in the recent past. That doesn't mean that the cuttings don't have issues, though. Those issues typically are things that are more chemical in nature as far as a concern to human health and the environment. They can be broken down into metals, salts, and hydrocarbons as broad classes, and then within those broad classes you can talk about, from a metals perspective, lead, arsenic, mercury, chromium, and then the salts vary. They can be sodium chloride, calcium chloride, potassium chloride, or any other of the type of salts that may be encountered downhole, or what is in the drilling mud itself to assist in shale inhibition. And then the hydrocarbons can either come from the producing formation while you're drilling into it and through it, as well as they can come from the drilling mud themselves, such as from oil-based muds, which once again act as shale inhibitors. And so those things have to be dealt with when they come back to the surface in one way or another, or they will affect human health and the environment.
How are you handling removal of cuttings that are high in something such as lead or arsenic, as you said?
We handle that through the technology that we offer, and basically the concept there is sequestration. That's both chemical in nature as well as physical. We create concrete-like monoliths with our technology that basically encapsulates the contaminant and does not allow it to mobilize in the environment. One of the things that's used to measure that is unconfined compressive strength. In other words, how strong is the monolith? And another one is hydraulic conductivity, which is a measure for how easily water moves through that material. If you do not have the ability for water to move through something, then it can't pick the contaminant up in order to move it into the environment. And that's an extremely important part of the technology that we offer. I would like to mention that very similar types of technology have been used, at least from a sequestration perspective, on federal Superfund sites. And the EPA has awarded contracts to people who have gone out and utilized solidification and stabilization technology in order to treat various contaminants at various sites across the country. For the small amount of water that does get into the system, you measure the leachate of what comes out of it. If you take unconfined compressive strength, hydraulic conductivity, and leachate as a three-pronged attack in how you measure and evaluate what you've created to sequester the contaminant or contaminants, that's how you are able to make sure that nothing is getting into the environment that would be of concern to both human health and the environment.
And this is one of the more interesting parts of the technology is your process turns this solid waste into a valuable, if not saleable, product. What's it used for?
That's really interesting. When we talk about things that we just spoke about, what we were able to do is take that material in conjunction with looking at subgrade strength of the soil that was in place out in the field and treat the material in a manner to create a concrete-like material so that it would support loads and have direct traffic action back on top of it. The result of that is that we are able to create load-bearing structures that meet criteria in order to be able to support loads without failure that can be measured as ruts or rutting.
Well, most of the time when I'm out in the oil field, a lot of the material that's used for paving those roads that aren't basically dirt is caliche. How does that compare to something like that?
Well, that's a great question, Jay. I mean, first of all, let's briefly discuss the differences between the usual upstream oil field construction and traditional construction that might be for commercial sites or for roads. Oil field construction rarely, at least onshore, has any type of civil design associated with it, which, if you start looking at the estimated miles of lease roads that have been created by the oil and gas industry, it's a phenomenal amount. I mean, it's tens of thousands of miles of lease roads. And if you take the view of a traditional civil engineer in road construction, the point of designing a road affects not just the drivability of the road, but also how often you spend money to go back in and rework that road, and that's called life cycle costing. The traditional oil field approach has not been one of engineering. It's just been putting down caliche or rock or something of that nature in order to be able to meet an immediate demand. If it fails, the term typically in the oil field is, well, that was just a bad location. Now, that's not something that a highway department would ever tell you. So what we've done is look at how you would design a road or a drilling pad in order to be able to meet a demand so that you're not having to go back in and reconstruct that continuously and therefore save the company money. In doing that, what we design to is a specification based upon a certain number of load applications going across that road at a certain weight with less than 1 inch of rutting. And that depends upon subgrade strength, the strength of the material that you're creating, and the thickness. So a simple, answer to your question is what we create is much stronger than what is traditionally built in the oil field.
And then what usually happens after all the drilling is done, all the fracking is done, and all the crews go home is a lot of times the idea is they go back to nature. I've always been curious about those frack pads that are caliche, and do you ever take that stuff up? What usually happens to the cuttings that make up the roads? Do you haul them away or bulldoze them over? What usually happens?
First of all, once the well's drilled, it's going to be produced for 20, 30, 40 years. You're looking at an infrastructure there that needs to be in place for quite some time. At some point, as you're indicating, there will be an end to that well and something needs to be done. Usually what we recommend to the operator is that you work in conjunction with the landowner on where you're placing the roads as well as the pad, because the landowner needs access back into property. They don't even need to take that back up. That's something they can use from now until whenever they decide they don't want that road anymore, as well as the pad for storage areas. However, at the end of that, even if they didn't want to do that, you can take the material back up and reuse that material again for other purposes. It can also be reused to build county roads, or you can haul it to a traditional landfill for disposal.
What were operators doing before your recycling technology came along to the cuttings? Were just landfilling them?
Well, the traditional methods, and they're still being used a great deal because, as you know, the oil field is usually very slow to adopt new technology. Traditional methods are burial without any kind of treatment, land spreading, which means you spread it over property in order to dilute it. There's land farming, which is spreading something especially that has a hydrocarbon content to it out over a piece of property and continually disking it or fertilizing it until it gets down to an actionable level, and then land filling. But those methods, even though those have been the traditional methods, they're still used a great deal and quite often in most states in which we operate.
Sounds to me like all those alternatives to what you guys are doing, seems like there's a lot of cost associated for the operators in that, right?
There is, Jay, and it's a cost that you get no value back out of it. In other words, it's just a disposal cost. What we do in recycling of the cuttings is you're able to get some type of value back out of what you have generated as a waste and turn that into a legitimate product that has real value for you so that you don't have to go out and buy a new product. And your cost is reduced, and that makes it a very cost-effective solution. We strongly believe that legitimate recycling is something that allows you to be able to be cost-effective in today's dollars. However, we also believe that the long-term benefit to the customer is that they're also able to receive future cost savings for things like not having to repair their roads as often.
I don't want you to give away your business model, but I've got to wonder, does an operator pay you to both take the cuttings? Do they give it to you for free? How does that business transaction take place?
It's really a rather straightforward approach because we do not commingle anybody's waste. That's another real environmental benefit. Operator A's waste always remains with Operator A. What the oil and gas operator is doing is paying us to be able to come in and treat their waste and build their next lease road or drilling pad. That way, they're paying us directly for our services in order to be able to utilize our patented technology and our construction services to create that material. We are a design-build firm. In other words, we design every job that we do in our own in-house geotechnical lab, and then we actually perform the work. So there's a phenomenal amount of benefit that the operator obtains from us in both engineering design as well as operational skill. From having processed hundreds of thousands of cubic yards of this material and built hundreds of drilling pads and miles of lease road, we also have an amazing amount of information about the waste, about various types of waste, how you should handle it in particular situations, and how it behaves.
Any metrics on how much the operators are saving using you guys as opposed to business as usual?
You know, it varies. The real variability here is that there is no uniformity from state to state in how this material is handled. That changes dramatically in how much money we save somebody. For instance, in North Dakota, you can bury the material back on site if you add some type of chemical drying agent to it and bury it in a liner, or you have to haul it off site to a landfill. If you come back to a place like Texas, Texas allows burial if you get the liquid off the material back in a reserve pit. Then they also have landfilling. You go to Oklahoma. Oklahoma has some very clear rules a lot of companies are using. My point here is you have a tremendous variability in rules from state to state.
How'd you get into this business?
My family and I started this business in 1994 as a traditional oil field service company, and we were doing traditional things such as pit closures and building pads traditionally. As we dealt with drilling waste, we thought there has got to be a better way to deal with this rather than these traditional methods of burial and land spreading and land farming and just hauling it off and putting it in a landfill. And after a tremendous amount of research, came up with the ability to recycle this material in a legitimate fashion and it not be considered some type of sham recycling, which really is not the sustainable long-term approach to doing anything. We wanted to find a way to recycle the material in a sound scientific way that truly long-term addressed sustainability for the industry.
Why do you think that your business model isn't more widespread? Why do you think it's not more as a standard practice among operators?
Well, the oil and gas industry is viewed typically as an industry that is slow to adopt things. I believe that most industries are. However, I will say that if you look at the past of upstream oil and gas, there has not been a tremendous need for looking at the environmental aspect of what was going on. There wasn't as much of a need for that up until really horizontal drilling came into play, and that has to do with waste being generated, in other words, frac, flowback. You're entering an era where we have an amazing resource, but it also means that the way that we have to deal with the byproducts of that has needed to develop. You have somewhat of an old mindset that their waste didn't need to be looked at as closely from an environmental aspect as it does now.
I'm thinking about that. You said you've been in business for about 20 years. In the last 20 years, I think there's been about half a dozen boom-bust cycles in the oil price, probably.
Yeah.
I'm curious, do you get a better reception when oil prices are lousy and people are looking for ways to save money, or when they're more robust and maybe the operators are looking for something a little outside the box and they have a little bit of extra money to throw around?
That's a great question, Jay. What we find that's really fascinating is the best time is when oil prices are not too high and they're not too low. And what I mean by that is when they're really high, or what some people in the financial world call a lot of froth in the industry. There's so much money being made and floating around that people can become careless in the approach to the things that they're doing. On the other hand, when the price is really low, companies are willing or needing to cut costs so dramatically that sometimes short-termism takes over rather than a long-term approach. And part of that short-termism is, even if you can save them money, it would require some evaluation on their part, and rather than doing that, they just stick with traditional stuff. And I think that low prices also bring out bad actors. What I mean by that is people sometimes are willing to do things that they probably wouldn't do normally just in order to save some immediate cost. In the long run, what we've seen is if you have middle pricing, that's when people are really not as concerned to make choices that are not necessarily in their best interest, but they're also not making so much money that they don't seem to mind whatever's going on.
That's a great answer, by the way. You mentioned working in all the different states. I was a lobbyist for the coal industry for several years before I got involved in a lot of water treatment. I'm curious, have there been states that you've operated in or tried to operate in where the regulations almost made it impossible because you are using what may be considered waste? Have you had trouble being able to take a waste and use it for the purpose you're using it for?
Absolutely. I can tell you that there are states that are much more difficult to operate in than others. And the answer, as most things, is not as black and white as it may appear. Pennsylvania is typically very stringent from an environmental perspective. But I had a regulator in Pennsylvania tell me Pennsylvania is tough on regulation because they had gone through the Industrial Revolution where a lot of waste had been left behind, and they're still cleaning that up, and that they don't intend to do that again. That makes sense. I can't say that I necessarily disagree with that. It makes sense to be careful about something that you don't want to have to everybody be able to get the reward, and then that's been 100 years ago. That over 100 years later, you're having to clean up something that if you'd have just dealt with it right initially, you would have been better off. Now, that's not to say, though, that they shouldn't be receptive to new, truly scientific approaches to dealing with something. The flip side of that is that there are rules in certain states out there that are extremely lax. What that allows is operators to go in and do things that they're legal. That creates an issue, too, because it's difficult to go in and talk to somebody about doing something that is clearly beneficial for the operator, beneficial for the environment, beneficial for the state, beneficial for the community, when legally they're allowed to say just bury something without treatment, which is not beneficial for anybody.
Let's talk a little bit outside your business model. Do you see yourselves using this technology outside the oil patch?
We are always looking for new ways to try to recycle something, and anything that we believe has a real opportunity for disruption, we take a look at.
Well, not giving too much away, has there been any discussion about possibly using these cuttings in conventional concrete and aggregate?
Not from our perspective. We've never had an operator that actually wanted to have their cuttings utilized for that, simply because of the value that they wound up seeing in the cuttings themselves.
Okay. Do you ever see yourselves going international? They drill in a lot of different places.
We're not opposed to that. The opportunity has been so great inside the United States since the horizontal drilling really started taking off since 2000, and we just haven't pursued that. Not to say that we wouldn't. The demand's been large enough internally to stick with the place that we know.
A lot of low-hanging fruit right around the tree.
That's right.
I'm going to add one more question here. You're in Longview. Okay. You're in East Texas. I'm a Shreveport guy. It's so weird. When I worked for several oilfield services companies in Fort Worth, they would go to South Texas, Oklahoma, West Texas, and never thought about going east of 45. I don't understand that. So why do you think maybe sometimes East Texas gets forgotten in this equation?
I think that a lot of that has to do with the age of the oil field in East Texas. Clearly, West Texas is a very old field, as well as South Texas. But generally speaking, I think that for a long time, people thought that the heyday in oil and gas in East Texas had somewhat passed up until the Haynesville came back around. It just was viewed as its day had come and gone, and that's the way people looked at that for quite some time. However, I'm almost certain of this, Jay, that it came from the USGS, but there was a recent report within the past 6 months that details the unbelievable resource that the East Texas Basin holds in oil and gas. I think that what we'll see over time is somewhat of a resurgence of the power of the oil and gas in the East Texas Basin.
Well, let's hope so. I just always, I was like, guys, it's 2 hours away, and you guys want to go to North Dakota? I never, come on. Okay, going to finish up with a lightning round of your thoughts on different energy technologies, your thoughts on all these different energy sources out there. Natural gas.
Wonderful opportunity.
Crude oil.
Something that needs to remain with us for many years to come, but I think that the stronger fuel source going forward will be natural gas.
Nuclear.
I don't see that occurring for the U.S. for anything in the near future.
Coal.
I think coal will continue to be a part of the mix, but I think that it will diminish over time simply due to, and only due to, the fact that it is going to be more expensive than natural gas.
Wind.
I think that wind will continue to play a larger role in our energy mix, but I don't see it dominating anything simply due to the amount of energy that we consume.
Solar.
I would say that solar will continue to grow and probably dominate even more so than wind will, but before it ever gets to the point that it truly takes over the majority of what we offer, you're talking about decades.
Biofuels.
I don't see biofuels really offering a great deal in the future.
Fuel cells.
I think fuel cells will increase and grow in nature.
Hydroelectric.
I don't see hydroelectric doing much more than what it's doing now.
Geothermal.
The same.
Electric vehicles.
I think electric vehicles will grow. I think that especially in metropolitan areas, people will use electric vehicles more and more. I think that the biggest thing that has to be overcome for electric vehicles to be utilized is how quickly batteries can be recharged and replaced.
And finally, nuclear fusion.
That would be amazing. That would transform the world. That would be something that I think would solve energy problems around the world from now to the end of time. However, the engineering involved in that, I just don't see being there for an unknown amount of time.
All right. Blake Scott, thank you so much for your time.
Jay, thank you for having me. I surely do appreciate it.
You bet. That was Blake Scott, president of Scott Energy Technologies, a Texas-based oilfield services company. A little more about Blake. He was recently named finalist for CEO of the Year in the Platts Global Energy Awards, a huge honor. He's one of 7 CEOs from 7 countries, and the winner will be announced December 7th. I'll recut this episode with an update once the winner is announced. Good luck, Blake. Thanks again to Christian Goff at Pure Energy PR for setting this up. One of the joys of doing this podcast is reconnecting with old friends throughout my career. All guests are sent the finished and completed show the week of release to ensure they are represented fairly. So far, no complaints. Be sure to check out pics of this show at Host Energy on Instagram and energy-cast.com. Music was produced by Sean Stroop at Stroop Loops. That wraps up episode 26. Be sure to join us next week when we discuss energy efficiency and the increasing role diversity plays in our energy mix. Until then, I'm Jay Dowenhauer. We'll see you next time.